Right now, let's look at data storage approaches. Right, this topic is something that you guys may have or will come across when you cover databases. But I expect that some of you have already done that course. It's the database course, or you have come across databases in either first year or second year. You are familiar that we have what are called NoSQL databases, which are becoming very popular in cloud computing for a number of reasons. Some of the reasons relates to the characteristics of these NoSQL databases. For example, they have better horizontal scaling capability. When we talk of horizontal scaling, we are looking at a scenario where you can simply, produce a copy of a server. They also have improved performance for big data. In other words, they can quickly store. Read writes are fast because of lack of constraints on the data. Then there's the next one is the reason why they have improved performance. The less rigorous, consistent models. Consistency is where you do a number of checks before you can store data, or you can accept a piece of data item. You can't introduce a piece of data item that changes the state, the valid state of the database. So checking that process takes a lot of time. So for big data, you don't want that overhead. Also, it is some of the reasons why there is less rigorous consistency checks is because there are no ACID guarantees. In other words, those things for transactions which are atomicity, consistency, isolation, and durability are not guaranteed. They sacrifice the ACID guaranteed or ACID properties for the database in order to gain performance. Of course, it doesn't mean that's nice. It may not be a nice thing, but at the same time, checking for ACID, ensuring ACID properties is an overhead which can slow down. It slows down the relational database. Right. So you have also what is called eventual consistency. Updates are expected to propagate eventually through the system. You don't have to have them, applied immediately, which of course increases performance as well. So you can guarantee best, which means basically available soft state eventual consistency as opposed to ACID properties. So they define their own, relaxed properties which are ensured. For that reason, it achieves high scalability, fault tolerance, and availability by sacrificing all those desirable properties for databases. So these databases are quite popular and involve massive data, semi-structured and non-structured data, and especially where real-time performance matters are more important than consistency. So if you really have big data and you want speed for the database, then you choose NoSQL databases. Right. Now there are a number of NoSQL databases that you may consider. There are those that fall into the class of key value stores, which store unstructured data and they have no schema. Then there is document stores, which are semi-structured data, which store in form of documents. Examples of these are XML, JSON, BSON, and YAML. Notice that these may be schemaless, or they could have a schema. You have an option. Like JSON has got a schema, XML has got a schema, but sometimes these databases don't really require any schema as such. You also have graphs databases, which store information as graph structures with edges and nodes. Of course, these are suitable for social networks and transportation systems. There are also object stores. We store data as objects as defined in object-oriented languages. So these are the various types, and of course your application it depends on what exactly you are doing for you to choose the right type. I will leave the rest of this topic to the database course, where you will discuss when do you use relational databases and when do you use NoSQL databases. And among the SQL databases, you also need to know when to use these 4 types of databases, right? But all of them could be potentially available in the cloud. That's what is important here, which means you need to make a good choice when you are implementing this. With that, we come to the end of this section and the topic.